Hello, everybody. It is January 6th, 2023, and in this meeting, we're going to discuss some work that Per has been doing in order to make the resolution portion of OLM a bit more observable and configurable. So with that, I'll hand it off to you, Per.
Right. Thank you, Alex. So we've spent the past 15 minutes doing a bit of silent reading of the document that you can see on the screen. Hopefully, when we share it on YouTube, we can put a link to the document as well. So first, we should do more of a discussion now. What I'll start with is just by asking what the sort of general impressions, if anyone is like super against this, or if there was information that you wish was there but was missing. Anyone?
I'll start off with a basic question, I guess.
Okay.
So this document obviously is pretty well written. I can understand everything pretty clearly. The one question that I had was, and I'm not sure if you left this intentionally vague for us to decide that during implementation, but then when you're talking about nodes in the pipeline, yep, what exactly are we thinking? Or did you have anything in mind? Like, is it going to be controllers that owns, I don't know, CRDs? So then input is given to them as CRs, or is there something else we're thinking about?
No, it's just a unit of that just does basic computation. So you have three types of nodes. So ones that just produce data, ones that only consume data, so like the output collector here, and ones that take in data and then produce more data. How these are implemented is up to the implementer.
Okay.
So it could be that the required packages, I don't know, has a watch against operator CRs, and keeps a cache updated, and then every time you run the resolver, it basically turns those into variables and pipes them down the pipeline.
Okay, so then the answer is we are not saying anything concrete right now, intentionally, to leave it up to implementation when we get to it.
Yeah, absolutely. I mean, but essentially, it's just a function that either produces variables, takes in variables and produces nothing, or takes in variables and produces more variables.
Okay.
And Per, are you imagining that like there's a box that you could draw around this whole diagram, or at least around part of it, which is sort of yet another abstraction to the thing consuming the entire pipeline, such that like it doesn't have to be the pipeline that's implemented like this from a total external consumer standpoint, but this is the way that we're going to implement that abstraction because it makes it easier for us to tweak it later.
So yeah, I mean, this at least the pipeline configuration itself can be declarative, right? And I think there's plenty of examples of that in the wild, like, I don't know, AWS step functions or something like that. So like, I haven't thought about it like super deeply yet, but the way that I would imagine it is we have some sort of pipeline CRD, which lets us, or lets the users define this structure. And we can always put validation on it, like it should always be a DAG, it always has to have at least one source and one sink, and things like that. But it just makes it all kind of configurable, the resolution pipeline. I don't know if that addresses the question.
Yeah, I don't know if you were trying to answer my or Alex's question, but like in my mind, like we could draw a box around everything except the output collector and say like, okay, this is called the resolver run function.
I see.
And it's literally a Go function that returns output or sat result comma error. And then, yeah, okay, our internal implementation of that is this pipeline, but it could be something else too.
Oh, I see. I mean, I haven't thought of that, but it certainly lends itself to that. I always just imagine it as surfacing the whole resolution pipeline, or maybe a good deal of it. So we might want to say that global constraints to solver to output collector is actually one node. It can be thought about logically as one node. That way we always ensure that the global constraints are applied. Doesn't matter what comes, behind global constraints. But that was about it. I mean, I thought, hey, let's make this whole structure, available to the user. I don't imagine that all users would even care about it, but it makes the system really transparent, that you can see exactly what's being executed on any cluster.
And then maybe to answer Onyx's question and also make sure that I'm also understanding this myself correctly, I think the intention at least is that like all of this happens within the context of a single process. These are all just little bits of maybe what you could consider like little libraries that are all connected via, a Go channel sort of thing or something, right? Like this is all in process, all Go code, all just, plumbing inside of a Go program.
Yep. I mean, you could also imagine another box here, which is sort of a little bit more generic, like similar to what we're thinking about for DEPI sources. Maybe you could have something like, I don't know, a variable source or a variable node, I don't know, online node, doesn't really matter. That when you plug it in on the declarative model, you can reference a particular, online source on the cluster by namespace and name, let's say. And they understand the protocol. So essentially, when the message comes down into that bubble, it sends it over the wire to some other node, which does the processing, and then it sends it back and then outputs those variables. Does that make sense?
Yeah, makes sense.
Yes, I mean, not like each of these is not one controller. Let's say everything is running in process.
Okay, so this is pretty cool because at least it reminds me of, like, for example, if you look at the core API server, it's got a lot of components before it admits a resource. So it's got the validating webhook and then admission webhook. So it's got different components, but then I think I'll have to go and, for me personally, look at how those are implemented and see, because like you talk about debugging, right? So if any of the node, if there's any failure in any of the node, again, this is probably, I'm getting way too ahead of myself because that's where my head is going right now. But then my thought, my thought process is, okay, so when there's a node failure, if everything is in process, how do I as a user have access to the node, the input and the output of the node?
So the way that I was thinking about it now, and I implemented a small demo, is basically each one of these nodes gets basically an event bus. So whenever it's consuming, it's taking off the bus, and whenever it's producing, it puts it on the bus. Each event has a sender and a receiver. The bus knows how to route it to the right nodes. And if one of these components throws an error, you will actually notify all of the nodes in the network. Again, this is a logical and process network, not a physical Ethernet network. That there has been a failure and everyone will bail their execution. So, and then you will know from the state of each of the nodes whether there's successful, failed, aborted, whatever it may be. You can find out exactly who failed, and also by monitoring the event bus, you get access to all of the information being that's traveling through the network. So you can catch that error message, who sent it, so where the error is. So there's different ways to be able to sort of catch that.
So one thing that this might lend itself to, if anybody's familiar with the Go error group package, that it's basically like a wait group, except the functions that you call as Go routines can return errors, right? So the idea is, I don't know, Per, if you've looked at this or whether this makes sense here, but essentially like you can set up this error group and then you say like, okay, run all of these things with Go routines effectively. If any of them return an error, at the very end of that error group, you basically say like, wait. And if, you know, if an error happens, then wait returns an error. If an error doesn't happen, then wait doesn't return an error. But the error also causes the other things to be canceled, I think. So that in my mind, when you describe it that way, like that's sort of what I think of essentially, which is the error is sort of global. And at the very end of this whole pipeline, the error comes out.
Yeah.
If it's one. The other thing that, so I was actually talking with Per about this earlier this morning. The other thing that wasn't immediately clear to me, which I'll repeat and make sure I get this right, Per, but this is essentially like, this isn't something where we're just like turning on each of these nodes and then they just run forever. This is more of a, like, we're going to prime this whole execution with all of the right setup. Then we execute it and we expect everything to like propagate and complete during any given resolver's invocation, right? So like thinking about this from the operator controller perspective, when we go and we say like, okay, you know, some event happened and we want to re-resolve everything, the operator controller is going to basically like instantiate this same pipeline again and run it once, and then it'll be done and we'll get the result out, and then we'll propagate that back to the places that we need to propagate it to. So it's not like this thing just like stands up and then runs for the duration of the operator controller.
Yep.
Okay, so then that means, for example, if we have a requirement for a new constraint tomorrow, then that is essentially introducing a new node in this pipeline.
Yes.
Okay. So how do you imagine that's different from, for example, in today's resolver, if you want to include a new type of constraint, it involves making the resolver or writing code in the resolver that makes it so that it understands the new constraint. So are we thinking that in this case, this will be just, okay, you've got a boilerplate of what a node looks like. This is going to be, I don't know, a consumer node. So here's how to write a consumer node. So just go and include this. Is that how you're thinking about an improvement in terms of the current resolver?
So I think I'm just trying to organize my thoughts. So I don't think this necessarily solves that problem perfectly. I think it's an improvement in the sense that the architecture here is additive, and you actually don't need to go into the resolver and do anything. You can just write a single component, as long as you know the inputs, and you know where to put it in the pipeline and how to connect it to the pipeline, then it can be fed into the solver, right? So one avenue is to say, yes, okay, here's a new constraint type. Then I'm going to write a component which you know, takes in all of the, let's say, bundle variables, checks them for a particular condition, and then either mutates a variable that was created by a previous step, or introduces its own new variable into the resolver, right? So the advantages, as I mentioned, is you know, it's additive, it's sort of separate from everything else. You can also turn it on and off by editing the pipeline. So to find out that it's not helping you, it's not really what you want, you can take it out. But we can use a specific type of node as a foundation for building out these types of sort of generic constraints and things like that. Because ultimately, it doesn't matter what you do in the front end, all of that's going to get translated into a variable. So we could either imagine a node type here, which provides enough abstraction and extensibility for these different types of UIs to come in and, you know, become variables or convert input into variables. And, you know, does that help answer the question? Like, I think this provides a foundation for us to go into the direction of solving the problem of generic constraints without having to go into the resolver and make changes and all of these kinds of things. Like, it's just completely additive and optional. You just hook it up to the network and Bob's your uncle.
Yeah, no,
So does that help answer the question?
it does. It does.
Okay.
Do you
So-
do you expect this to the nodes to be defined as separate processes or everything contained within a single process? I mean, for extension, I'm hearing, you know, we're going to be creating custom resources. But everything also is in one process and yada, yada, yada. So I'm just thinking, how do you see this being extended in a more, you know, somewhat concrete way, or at least you know, do you see this as multiple processes? Do you see this as a single program that we would have to extend and rebuild, or can something be added to the side without having to rebuild everything?
Good question. I think, so as it stands now, it's just a little framework from which you can basically get input and output channels, right? And you know where you should route your answers to. So in that sense, they're all running in their own, at least their own Go routines. Now, where we might hit a wall is, you know, I'm going to create a new type of bubble. Now the code needs to know about that bubble, right? But there's different ways that we can get around this by, you know, creating bubbles that speak a different protocol, like, you know, HTTP or gRPC. Then, but you still need to know about that type of bubble in the pipeline. Though I imagine we could try and figure out ways to make this more of a plugin type thing. Does that help?
Kind of. I mean, it just saying right now, you know, this is very pie in the sky. This is very high level. And, you know, I'm sure as engineers, a lot of us think very concretely.
Yeah.
So, you know, where this doesn't really elaborate on is, you know, is this, and I'm just not asking you to answer this right now, but is this something where you define, you know, various Go modules and the Go modules all are linked together into one single application? Or are we talking about something with some more connectivity to other processes that can supply input and output and thus via some type of custom resource be linked together? Either, you know, as like, okay, just throw out an example, you know, you mentioned HTTP. It's like, okay, we're adding this, we have these 10 nodes, and the first node is, you know, a predefined node within the resolver. And the second node, however, is defined in this process that you communicate via, you know, HTTP and get results back via the HTTP response. And then the next 3 through 10 nodes are predefined and you want them in this particular order.
Well, pretty much that, right? But the thing is that the node that speaks HTTP will have to be known by the pipeline, if that makes sense. So,
right,
so
but what
as
I'm
it
saying is the
yeah.
pipeline is defined as, you know, this custom resource,
Yeah.
you know, with nodes 1 through 10, and you define node
Correct.
number 2 as an HTTP resource. That
Yeah.
custom resource now has the information that hopefully the resolver can take and know how to communicate. Because I mean, a lot of this has to do with, you passing events around and as
Yep.
some type of messages or error, data or whatever.
Yep.
So, an event can be just talking out to an external process and getting a result back.
Mhm.
Yeah,
Or, it could all be an internal thing where you just where the custom resource or the configuration just really defines the ordering and the linking of the predefined modules or the predefined nodes.
So that's the case. So essentially, I just imagine a declarative way to define this structure. So you might have, I don't know, node type, required packages, or something like that. Outputs are bundles and dependencies and solver. And then the same for, each of the bundles, right? So the palette of nodes that you can pick from will be fixed.
Okay, so it's not like an extensible through a separate process. And if we wanted to add a new node, there would be a programmatic method to do so that would have to be, would basically cause a rebuild. Okay.
Yeah.
But it seems like, so again, correct me if I'm wrong, but what it seems like to me is that like the actual pipeline itself is all implemented in a single program. Each of the nodes can do essentially whatever they want, right? They could be totally static, part of the, talk to a network. They could read from the disk. They could read from the network. Like they can do sort of whatever they want as long as they implement the interface of whether they're a producer or consumer or one of the nodes in between. But to the point of like how extensible this could be, like we could totally just write like the HTTP node that we send all the input to the HTTP server, and we expect the response to be all the output. And then at that point, like it's completely wide open what the implementation of that particular node does. And that node could then later, well, the HTTP server that node is talking to could make yet another network connection if it wanted to, right? But like, I think from the perspective of this diagram, everything is inside of a Go, like each of those circles or squares is a Go routine in a process. And the Go routine does whatever it wants within the bounds of the interface.
And one of those Go routines could be configured via a custom resource to say, go gather information from this URI.
Right. It could be anything. Yeah.
It's just that the code underpinning that particular type of node would need to be compiled in with the pipeline, that's all.
Right,
Even
but it
if
would be
it's externally configurable, right?
But it could be extraordinarily generic. Here, make
Yeah,
this
right.
request make this request to this particular node, and as long as they follow the data, as long as the data is formatted,
Right.
Properly, it ought to be able to understand the result.
Yep, absolutely. So it's extensible in that case, in that sense. Like we can define a protocol for node computation that happens outside of the process. So the communication protocol for that. And then observable, right? You just have one thing that's the client and it knows where the server is. And then when it gets an event, it pipes it to the server, waits for the server to come back with a response, gets the response, pipes it to its outputs.
But you don't even have to, I mean, in terms of like the spec of this, like that protocol also doesn't really matter. What matters is that the Go routine itself consumes variables and pushes out variables.
Right.
Whatever, right? Like if we say like, okay, day one, we're going to build an HTTP protocol that looks one way, and then someone else says, well, that's not great. I want to do I have a streaming protocol that I can use. So then we go and build that. Like the underlying protocol doesn't matter as long as that node speaks the right language in terms of this framework.
Right.
Okay. So
Right, but that node would have to be built into the solver code.
Yeah.
But what I'm saying is you could define generic ones that use gRPC or HTTP, and as long as those, the API is well defined in within those protocols, then that provides a ridiculous amount of extensibility.
Yeah, exactly. So like I would imagine, if we have, I don't know, a gRPC or HTTP service, and then, I have a new type of constraint, and no one from the OLN team is listening to me. So then you can just bring up one of those servers, which does the computation that you want. You know, looks at the variable, extracts the information, creates a new constraint or a new variable, and then pipes it back. And then you can just go and edit your resolution pipeline and say, oh, in here, put a whatever gRPC node in this part of the network, and the name of the address is this, the port is this, whatever it may be, and then Bob's your own.
And then you could also just saying is this could also, that extensibility could also be used for additional debugging.
Yeah, absolutely.
By adding a new node, say it somewhere in the middle or in the end or
Yep.
whatever, gets the information, pushes it out,
Yep.
dumps it out or
Yeah.
something, and then and then just returns
Exactly.
back the exact same stuff. So doesn't really change anything. It just simply reports it
Yep.
in case we have some visibility problems.
Exactly. So the way that I went about, at least in the demo, was just to have like an event hub that knows everything. So then I just expose a debug channel of that. And then you can just read every single message that's going through the pipeline. And then you can just, you know, graph for the particular edges that you care about. Or you know, the boundaries of a particular node that you care about.
One question, pair, which is, I'm gonna change the subject a little bit, so hopefully that's okay, but how does the solver know when to solve? Is it when all of its inputs have closed?
Yeah.
Okay.
Exactly. So basically, you know, required packages will go and put out its variables. It's a finite amount. Once it's finished, it completes. Same for install packages. Then it'll go into the you know, bundles and dependencies, and it'll do its work. Eventually, it runs out of input, so then it completes. Same again for global constraints, and then finally, the solver just sort of sits there, collects all the variables that it gets, and then once it gets notified, okay, input's up, then it knows it's the time to solve, and then it pipes that out to the output.
Perfect, thanks. I've got another question which I put in the comments. If no one else has any other, then I'll just keep going. So feel free to interrupt if anybody else has one. But I put a question: why do we need installed packages to be fed into the bundles and dependencies? It seems like installed packages would only ever come into play when you're trying to eliminate. Oh, maybe that's what it is. Are you pre-eliminating possibilities in the bundles and dependencies block such that?
Oh, no, maybe this was just an oversight. Like, wait, I'm just trying to think. Yeah, I don't know. I have to think a little bit better about how the install package variable would be created, but I'm guessing it would just be the bundle itself with a mandatory constraint. In which case,
That's probably not what we want though, right? Because
you don't need to. I'm just trying to think. Yeah. So maybe actually it doesn't need to be piped in there. It can just go directly into the solver. I think you might be right.
well, I guess what I'm thinking is that like the reason that you want to know about installed packages for the solvers is to be able to know like what you can upgrade to, right?
Mhm.
So I guess like wherever the thing is that eliminates the possibilities from the bundles and dependencies list that says like, okay, well, you asked for package foo. There's 15 different versions of package foo. I see that you have package foo version 3 installed. And so I'm going to eliminate all the other ones other than version 4.
Right. So in which case, then you'll probably have a dependency constraint with all those bundles there. I'm just trying to think. Yeah, yeah, from the top of my head, I'm not sure, but yeah, I think that edge could be wrong. And yeah, I don't know, I have to think. Maybe what we would need to do is somehow either mutate the one that we have or just create a new variable, which is similar to the required one with a reduced number of dependencies. So you might be right.
Yeah. Okay.
Even the required packages, because like it looks like at least this pipeline diagram, it's walked back from the current resolver, which takes subscriptions, and then it says that these are the required packages, because subscription is an intent to install a package, but then in the new resolver, are there actually going to be, or are we, is there anything going to be that says these are the required packages because there's no subscription? So essentially, I'm thinking that from Joe's question, the thought that I had was, is the required packages also going to be a thing? But that's probably a nit, at least in terms of this pipeline diagram.
Well, the required packages is basically the intent to install something, right? So it might be that looks at the either one operator CI or all of the new operator CIs or all of the operator CIs that are have a particular state or whatever it may be. And then generates variables from those.
Okay. So install packages will be the bundle, Ruckpack bundles, and then required packages will be the operator APIs.
So installed packages would be stuff like maybe operator CIs that are already in the installed state, for instance. So there are things that are already there and must be in the solution because they are already pre-existing.
So it seems to me like if we're trying to be concrete about this and think about like how would we do this today if we had all the code ready, it seems like to me we probably have the operator controller know what the installed packages are and know what the required packages are. Like it's the thing that produces those things, and then we can feed that stuff into the rest of the pipeline. Like it's the operator controller that knows all of that stuff.
Okay. Makes sense.
Oh yeah, sorry, you go.
I was just, well, I'm going to change the subject again. So if you were going to say something about this, then go ahead.
Oh no, nothing. You're good.
So I had another question, and I don't know if this is really super relevant to the pipeline sort of architecture design, but more just in general about resolution. And I think it's relevant to some of the discussion we're having about extensibility and, if I want to add a new constraint, what do I do and that kind of thing. But the question is essentially like, and I think Alex maybe had a question about this in here somewhere, but an example, like the example of the OLM version range constraint, or I'm sorry, the OCP version range constraint.
Mm-hmm.
Like a bundle says like, I must be on this OCP version range. How do we, there's multiple ways to interpret that, right? Because like not all clusters are OCP, obviously. So, and then maybe not all OLMs are going to know about that OCP version range constraint. So I maybe this isn't the right place for this discussion, but I think it's probably useful to think about the intersection of what constraints are implemented by the pipeline versus how we interpret those constraints if they show up in bundles. Does that make sense?
Yep.
And
So
then,
whether something is more of a property or more of a constraint, like your system must meet this requirement.
yeah, and
the thing to be installed, right?
Yeah, and I think part of the problem is that like people have asked us before for somewhat like optional requirements, sort of.
Yep.
Which like I think we pushed back a little bit because it doesn't really make much sense. But maybe what they really are asking for is like this Boolean logic, which we sort of have right now in OLMv0, but it's not really tied into the actual resolver itself, so it falls down in several ways.
Yep.
So I guess what I'm asking is like, if someone says like, I either need to be on OCP version 4.12 or greater, or I need to be on, EKS version something or greater, but I can't go on plain cube, right? Like
Yep.
for what reason? We probably need to have an answer for that. And I think that's probably like this idea that we've been talking about for like a year and a half or two about the whole runtime logical Boolean constraint things, which is not trivial. So I don't know, just throwing that out there.
So yeah, I don't have an answer to that, and I think it's an important question. I think that we can at least constrain the context of the problem to really just solving that problem, which is I have some arbitrary input and I need to produce variables. And then that particular thing just becomes another node type here that we can very easily route into the solver. So while this probably, like as it is now, doesn't solve the problem, I think it makes it easier to include into the resolver once we do have a solution.
I think that, so I think the thing that we ran into is that, and maybe this architecture fixes this problem, but from what I remember, we built the logical Boolean constraint stuff based on like effectively just like filtering things out.
Yeah.
Rather than teaching the resolver about how to do logical ORs over things.
Yep.
And I think we came to the conclusion that that has the potential for like getting into like local minima, local maxima, where like if the solver actually knew about the logical or the, you know, the Boolean expression, that wouldn't happen.
Yeah.
So we might need to actually make the solver smarter and like have another type of like you know how right now we have like at most one of or at least one of, like we might need a or and an and, like make those take a list of other variables or something.
Yep. Yeah, absolutely. But then that's like one level down the stack here. Then it will be what the solver itself understands.
Right. Yeah.
So, but then we have to figure out what these primitives are, and then basically every constraint within a variable will respect, you know, these primitives, which I think would give us, like, as long as we have not and or, I think that should give us enough expressibility to do basically anything.
Yeah. Okay, and then my last main question I think is around, and I've asked Per this, and I'm sure other people have heard me ask this question too, but I'll just repeat it here, is around like in this context, what happens when a bundle has a constraint that the node doesn't know about, or that like, well, actually, maybe this is an even more important question, because it's like each of these nodes processes some subset of the constraints that it knows about. When we get to the end of the pipeline, how do we know that we've processed all of the constraints?
That's a good question. I don't have an answer for that. But I think it's the same problem whether we use a pipeline or not. In the sense that this is just an inversion of what we already had already.
Well, I guess there's, you could invert this and say like, okay, I'm just going to look at every bundle and I'm going to iterate all of its constraints. And I'm going to then look up the node that I want to implement that constraint with. And if that lookup fails, then I know that I have a constraint I don't understand.
Yep. That could be one way.
But the reason I think that's important is because in my mind, a constraint, if a bundle specifies a constraint that the resolver is completely unaware of and doesn't know about, I think at least by default, that should just be resolution failure. Like the operator author has stated some intent that we do not know whether we can satisfy. And maybe there's some configurability here that we want to give to cluster admins, which is like a knob that says like, well, what do we do in that situation? And maybe that's even like per operator. Yeah, or like per required package knob, even potentially, I don't know. But anyway, that's just another thing to consider here.
Yeah, it sounds like it probably need a little bit more. Sounds like it'll that is an interesting thought, because like I'm thinking about different scenarios where I as an operator author included a constraint, but I've also written a node for it, an external node that understands this constraint. But then I want to I want to ship this bundle to different catalogs that works in clusters that do not have that node. So then by that logic, my bundle will fail resolution in those clusters. in today's world, I think we just ignore it. Like, for example, max OpenShift version, if that constraint is there, and then if you run that bundle in a kube cluster, I don't think it fails resolution, right? So that sounds like that's the expected outcome of that, that if you don't, or even if suppose I turn off one of the nodes, that means all of the bundles that were supposed to not fail in resolution will start failing now. If, for example, the thing that Per said before, that we have a CR that like a node CR that kind of we can turn on and turn off particular nodes. So then if I turn off some node, that means the resolver no longer understands particular constraints, and now all the resolutions are failing. So yeah, it sounds like there's a lot of ways we can go with this, but it sounds like definitely needs a little bit more thought.
Yeah, I mean, my first question would be, like, how big is the universe that we want to offer to operate authors where that becomes an issue, right? And I think what we need to think about is what's the distinction between a constraint and a property? And what's the sort of breadth of constraints that we want to be allowed to put on a bundle?
So part of when I was doing, I think it was like that demo for like Kuber Resolver or something like a year ago, where like I essentially like invoke a JavaScript runtime based on the contents of a CR that has some JavaScript code in it. The idea there was that like we might not know what constraint types a certain, like let's say we have a a telco company, and yeah, okay, we've got packages and GVKs, and like we've got our kind of known set of constraints.
Yes.
They might have like their entire own catalog where they have their own policy, and they say like there's this other constraint that is critical to our domain. And like the way that right now in OLMV0 this would work is they would have to come to us and say, hey, can you teach OLM about this particular constraint type? And it would be like, potentially like some really weird telco thing. We'd say, no, that's not generic. Like, we're not going to do that. But so I don't think we have a really good answer for that today. And so part of what I was thinking about there was like, can we make the actual definition of the constraint itself extensible, but still have some guardrails that say like, if like basically allow a customer to say like, here's some extra constraints that I want you to implement. And, and I still want the guardrails around like, well, if I have a bundle that doesn't specify that constraint, that's fine. If I have a bundle that specifies a constraint that I haven't mentioned, then that should be a failure or not. So essentially like, maybe there's like another node that just implements this full extensibility somehow. Yeah, I don't know.
Yeah, I mean, at the end of the day, it's variables and constraints, right? And you have some input, which is going to transform it into that.
Do you think there's enough meta? So say I wanted to insert something right after the global constraints box, and like, have I now filtered stuff? Like, I guess, is there enough metadata in the variables that are crossing over these lines that another box could know what it needs to do to edit that? Like, I guess what we're talking about here is like those variables are going to have at most one of, or at least one of sorts of things, or depends on sorts of things. Do we need to like know why those are there to make more decisions? I'm trying to think like, if I'm adding more constraints, how do I then start filtering some of that stuff that like a previous node sent down the pipe to me?
So I think you would have to know the variable that you're looking for, at least.
Like the IDs, right?
Right, or the features of the constraints that you're looking for so that you can match.
Yeah, so essentially like the nodes that want to actually implement their own constraint types would need to know all the properties of all of the nodes it's operating on.
Sorry, you cut out a bit. So
So
Hey, Kevin, you can-
say
yep.
a telco company said like, I've got a tower ID and I want to write a constraint that says like this operator is only going to support towers with tower ID, greater than 10 for, I'm making something up. If that's like later in the pipeline and I see a variable that says like, oh, food depends on bar and it can be bar 1, 2, 3, or 4.
Yep.
Then the thing that knows about tower ID needs to look up bar 1, 2, 3, and 4, and then filter that list down and say like, oh, well, actually, 1 and 2 shouldn't be in the list because.
Yep.
So I guess like that's the question. Like, is that a completely new variable that says like 1 and 2 are just prohibited, or is it an edit to the existing variable to remove 1 and 2 from the depends on list?
Yeah,
I think we can, both ways might achieve the same result. I just don't know what the trade-offs are.
This
I
might
guess
be
So that's the thing, we've got to be really careful with what we mean by constraints. And I think we need to start thinking in terms of variables and how they relate to other variables in the expression. Right? So you might, I'm just trying to think, yeah.
It seems like like if I were implementing this now that I'm talking through it, it seems like what I would probably say is that we don't actually need to know about the other variables that are being piped through from the required packages. All we need to know is I'm going to add a new variable that's mandatory that says that these other ones are now prohibited because they violate this particular constraint.
Yep.
Yeah.
So yeah, there's definitely a lot of different ways to skin the cat. And I would say still Padawan level at putting together these variables in the right way and trying to really understand what the different trade-offs are and how to approach them. But I think that's something as a team we'll get better as we go along. But having said that, like I don't know that there's a silver bullet for people to just create constraints without understanding what the resolver is doing.
You mean when you say create constraints, you mean create
new constraint types
that implement basically like what we're talking about is like translating a constraint to a one or more variables.
Right.
Yeah.
Right. So I think we need to get better at that before we can start making the whole world available to the users, if that makes sense.
Yeah. Which essentially what we're talking about there is like dropping down and having like that variable API like really honed and easily consumable and grokkable.
Yeah. And
But
it's
then
actually fairly simple, right? I mean, we have a palette of constraints and we have an ID.
Right.
Sorry, we have a palette of constraints and a variable is an ID and a collection of these constraints.
And also the thing that we can look up the ID with, like the entity source, essentially.
So yeah, I mean, that would go into the node itself. Like
Right.
not every node would need an entity source, but that could be a type of node that gets access to that, like on the code side. And then you can go and query and find different things. Because yeah, that's another dimension of it. Like how do you create those constraints against other variables? You need to go and be able to find either the variables associated with particular entities or find the entities and then make the variables. So it's non-trivial, even if you know what you're doing. And the other thing is, I think you can express the same types of constraints that you want to express in different ways, but that will give you completely different error messages. One which might be very easy to understand, and another one which might be not so easy to understand.
But it seems like any, and maybe I'm not thinking about all the possibilities here, but it seems like anything that's actually going to implement a new constraint type needs to know about the properties that you kind of bang against that constraint, right? So like,
Yeah.
the IDs are sort of this opaque thing that mean nothing from a variable perspective to a constraint translator thing. So like the IDs are always just used to look up properties, and then you can come up with new IDs based on comparing the constraint implementation to the properties of the thing.
Right. But IDs matter for things like conflict and dependency and so on. You need to know who
Right.
you conflict against, right? But that ID, which I think is the point you're trying to make, could be really anything, as long as it's
Yeah, I
always
guess that's
representing
sort
the
of like,
same thing.
you can't really look at the ID by itself and say like, oh yeah, I conflict with that.
Right. Right. Unless you know what it is. But yeah, like, well, if you say like, I can never be installed along with package A, then yeah, you would need somebody that say, hey, give me all the bundles that you have that belong to package A, and then you just create a conflict against those or something like that.
Right.
But yeah, these are all good points. All right, I think we're like 20 minutes over, and we need to give a little bit of space for Daniel for a discussion about whether we do resolution, one operator CR at a time, or do we batch them, or how do we approach them?
Yeah, so the purpose of that discussion isn't.
One second.
So sure.
I want to cancel. I want to stop the recording. So
Right.
and then we can kick another one off.
Cool. Then just before you do,